Welcome to the XCS eiConsole for MISMO Getting Started tutorial. The MISMO XML standards provide a set of common messaging constructs to support core data exchange processes in the mortgage and lending space, including residential and commercial standards for processes from loan origination to appraisal, closing, and servicing. MISMO has streamlined workflow, reduced cost, and improved transparency across the industry. However, the implementation of standards across heterogeneous systems and entities does not come without challenges and costs. The XCS eiConsole for MISMO provides an integrated development environment which will facilitate the initial development and ongoing maintenance of MISMO-compliant interfaces. In this tutorial, we will use the MISMO Credit Reporting Standard to explore the XCS eiConsole's paint-by-numbers assembly line approach to developing integration solutions. We will develop an interface that accepts applicant data in a delimited file format and translates it into a MISMO-compliant credit request. Now let's get started. When you first open the XCS eiConsole, you'll see the route file management screen. The first thing you'll want to do to create a new interface is to click the Add Route button. When prompted to provide a name for the route, enter My Credit Request and click OK. A new row will appear in the route overview grid. To open this for work, select the row and click Edit Route. This will bring us to the main eiConsole screen. Here we'll need to define the flow of data between a source system and a target system. The source system will be producing a credit request, the target system consuming it. To add a source system, click the Add Source icon. To add a target system, click the Add Target icon. Our job now is to work our way from left to right across each stage. We'll begin with a source system that will somehow produce data to be consumed by a listener. Once the listener accepts the data, we'll perform a source transformation, first into XML and then into the MISMO format. Next, we have a routing stage where we can configure routing rules and transaction monitoring, which is exception handling. Next, we have the opportunity to apply a target transformation. Finally, we have a transport that takes the formatted data and passes it along to the consuming system. The target system then consumes the data. This can happen either in a real-time synchronous fashion or asynchronous or batch. We'll begin by clicking the listener icon. The first thing that we need to configure is how the data will be accepted by the interface. We do this by determining the type of connectivity that's most appropriate for the source system we're connecting to. In this tutorial, we'll be assuming that the file is dropped in a directory in the local file system. So from the listener type dropdown, we'll select the directory listener. Note that the XCS eiConsole supports a number of different types of connectivity mechanisms. Some of these mechanisms are proactive, meaning they go out to look for the data. In other cases, the data will be pushed to the listener. Examples here would be a web form posting data in or a web service call. But here we select directory. Once a listener type is selected, we're presented with a set of configuration panels. Those panels containing required configuration information are denoted by a red ball. Each configuration item that's required is also denoted with the red ball. Click the Basic Configuration tab, and in the polling interval configuration item, we'll want to enter in a frequency for how often we want to poll this directory for new files. Enter the text 10 in the polling interval configuration. Next, click in the text box to the right of polling directory. You'll note that once we move off of the polling interval configuration item, the red dot disappears. To set the polling directory, click the button to the right of the text box. This file-based configuration item will allow us to choose a directory to poll. Create a new folder called Input. Ensure this folder is selected and click Open. The full path to the polling directory will appear in the polling directory configuration. All other configuration information is optional, so we'll move on. Click on the source transform icon. The source transformation in an eiConsole interface is responsible for taking the data from the proprietary format of the source system and converting it into a common or canonical format. Typically, in our industry, we'll want to convert this data into a MISMO compliant format. To create a new transformation, click the Add Format button to the right of Format Profile. When prompted, enter the name CSV-applicants to MISMO credit request and click OK. The Transformation tab will appear. You'll note that transformations have two pieces: a transformation module that's responsible for taking the data and converting it into XML if it's not XML already, and then an XSLT stage, which is responsible for the logical mapping of the proprietary data into our canonical XML format. In the tutorial data folder of your distribution, you'll see a file called applicants.csv. This comma-separated file is the input to our process. This is the data we'll need to take and turn into an XML format. Reviewing this file in a text editor reveals that the first row contains column headers, and each subsequent row contains data. We'll need to take this data, convert it into XML, and then map it onto a MISMO credit request. To convert this data to XML, we'll use the delimited and fixed width file transformation module. Select this entry from the transformation module dropdown. Then, click the Edit button next to the File Spec configuration item. This will launch the XCS File Specification Editor. This tool is used to describe the delimited or fixed width file we wish to parse. When creating a new file specification, we're immediately prompted with Select for New File Type wizard. Since we want to import the field names from the headers of the CSV file, choose Import Field Names from CSV File. Then click Next. The field delimiter is appropriately initialized with a comma, so click Next again. Now, in the Open File dialog, we'll need to locate that sample file we pulled up in the text editor before. Select All Files from the Files of Type dropdown and navigate to the applicants.csv file in the tutorial data folder. Then click Open. When prompted to load the test file, click Yes. You'll note two things. First, on the left-hand side, a tree was created representing the logical structure of our inbound CSV. A green node depicts the record types within the file, one record type. The blue nodes represent each field or column in the file. Field names were taken from the headers within that file. You'll also note the complete contents of the CSV file have been loaded into the Results Preview tab. When using the File Specification Editor, the developer's job is to build this tree on the left-hand side. In this case, we imported this information, but we just as easily could have come in here and added fields and added records manually. Once this definition has been built, we can test to see how the file is parsed. To do that, with a sample file loaded in the toXML pane, click Execute Transform to XML. A tree will appear below, depicting the structure that we'll parse this file into. You note that it's located 3 records. The first contains the headers. The second and third were correctly parsed with the actual data fields. To avoid the extraneous parsing of the first record, click the First Row as Headers checkbox. Click Execute Transform to XML again. You'll note that only 2 records are parsed. If we were working with a fixed width file, it would become more likely that we might have some type of error in the parsing logic. To be able to review how the system parses a particular type of record, you can select a subset of your sample file, click on a corresponding record type, and click the Set Selected Text button. Now, as we navigate through each one of the fields underneath that record, the corresponding section within the selected sample will be highlighted. If modifications to the field definition need to be made, they can be made by dragging these blue arrows around, or by modifying the information beneath the record structure tree. But since this all parsed properly, we can save our file specification and move on to the next stage. Click the Save icon and enter the name CSV-applicant-spec and click OK. Then, click the Return to Console icon. Now that we've completed specifying the format of our input CSV, we need to map that using XSLT onto our canonical model, which in this case will be the MISMO credit request. All logical mapping within the XES eiConsole is handled via XSLT and the XES Datamapper. Click the Edit button in the XSLT configuration area to launch the Datamapper. The XES Datamapper has 3 panes. A pane on the left-hand side, which will contain the structure of our source data, a tree on the right-hand side, which will contain the structure of our target format, and then a panel in the middle, which will represent the logical mapping between the two, which is, under the covers, XSLT. We start by clicking the Open Source Format icon above the source format tree. When the Select Format dialog appears, we'll choose the Flat File Format Builder. This will allow us to use the file specification that we built in the previous stage to describe the structure of our input file. Similarly, we could use an XML schema, XML file, database, WSDL, etc. Once we've selected the Flat File Format Builder from the drop-down, we'll be presented with a list of flat file format files. Click the Add button underneath this area, and then navigate to the Formats folder underneath your working directory. You should see a CSV Applicants to MISMO Credit RQ folder. Choose the CSV Applicant Spec XML file and click Open. Then click Read Format. A tree will appear on the left-hand side that's very similar to what we just worked with in the file specification editor. Now, on the right-hand side, we'll want to load the MISMO Credit Reporting Standard. Click the Open Target Format button above the target tree, but this time, choose the XSD Format Builder. We'll be prompted to provide a schema file. We'll want to use the credit request schema as published by MISMO. This may or may not be included with your distribution. If it's not included, you can find this in the credit reporting section of MISMO.org in the specifications area. Click the Browse button, locate the specification, and then choose the credit request XSD. Then click Open. Now click Read Format. A tree representing the credit request standard will appear on the target side. As you navigate the tree, you'll notice a doc tag includes any documentation included within the MISMO schema. The next thing we'll want to do is create the skeletal structure of the transaction that we want to map to. Now, this could be done by dragging elements from the right-hand side of the tree into the center. But when working with a large file, that can become a little bit laborious. Instead, we'll load a sample and use that to seed our mapping. Click the View Sample Data above the target tree. Then, click the Load Sample Data icon. In the Tutorial Data folder, you'll see a credit request example. Select this file and click Open. This is a sample MISMO stream taken from the Credit Request Implementation Guide. Click the Close button. Now, to use that sample data to seed our mapping, under the Formats menu, choose Add Target Sample Data as Template. When prompted to load the values from the sample into the mapping, click Yes. A number of green nodes, or target output, should be created within the tree, along with a blue node at the root. Each green node represents an XML element or attribute that will be created when the transformation is run. The blue node, XES data at the root, indicates that this will occur for each XES data element in our input. Now, let's map a few fields. If we were to run this right now, what would be created would be completely static. The output would be essentially this target format sample data. What we'll want to do is replace some of the hard-coded things within the sample with dynamic values taken from our source. Let's leave the requesting party and receiving party alone. We can collapse those nodes to get them out of the way. In the request element, you'll note that the first attribute is the request date time. We'll want to replace this hard-coded value with the actual current date time that the transformation was run. To do this, we'll use our palette of functions above the center mapping. Select the Custom tab and the Date subtab. Then locate the Current Date Time tool. Click this and drag it on top of the Request Date Time attribute. The hard-coded value is replaced by syntax that indicates that we want to take the current date time and use it to populate this attribute. The second attribute is an internal account identifier. Let's say we want to replace this hard-coded value with a hard-coded value of our own. To do that, double-click on the internal account identifier attribute, select the existing value, and enter in one of our own. When you're done, hit Enter. It's important to hit Enter as opposed to Escape or just clicking off of a node within the mapping. Navigating away from a node without clicking Enter will replace the value with its previous value. Next, we have a couple of key elements. Let's say that our implementation does not require either one of these keys. Click on the key node, then right-click, and select Delete. Repeat this process with the other key node. The key elements and all of its children will be removed from the output. Now let's move on to the Request Data section. We want the Request Data section to repeat for each record in our input. To accomplish this, we'll want to use the XSLT for each structure. Select the XSLT Structures tab and the Flow Control subtab. Then, locate the for each icon. Drag the for each icon between the request and the request data nodes. You'll know you're in the right place when there is a bar above request data and request is highlighted. A blue for each node should appear. Since we want the request data to repeat for each inbound record, we'll select record from our source tree and drag it on top of the for each. Next, we'll take the request data node, the node that we want to repeat for each record, and make it a child of that for each. Select the request data node and drag it on top of the for each. Let's move on to the loan application node underneath the credit request. Expand loan application and expand borrower. Let's map each of these nodes from the top down. Beginning with the borrower ID, let's map the borrower ID to the SSN. Select SSN from the source record and drag it onto the borrower ID attribute. A simple one-to-one mapping will be created, replacing the hard-coded value. Let's skip birth date for a minute and map first name and last name. Map first name from the source to the first name attribute, and last name from the source to the last name attribute. Let's also map SSN to SSN. Next, we'll see birth date and unparsed name require mapping. First, let's look at the unparsed name. We want the unparsed name to be a concatenation of our first name, middle name, and last name with spaces in between. One way to do this is to double-click the attribute, highlight the hard-coded value, and then enter in curly brace, concat, first name, comma, single quote space, middle name, comma, single quote space, last name, curly bracket, and then hit enter. That's one way to enter in a dynamic value. We can also use functions from the palette above and variables. Let's do that with the birth date that requires a little bit more formatting. You'll note that our sample in the MISMO XML is in year-year-year-month-month-day-day format. However, our input CSV file uses month-month/day-day/year-year-year-year. Let's create a variable to handle this transformation. In the XSLT Structures tab in the Variable subtab, choose the Variable tool. Create a variable node directly above the borrower. A blue variable node will be created. Double-click on the name and enter formatted DOB. Next, we'll want to map the DOB onto the formatted DOB variable. Drag DOB from the source record onto the formatted DOB select attribute. Next, we need to actually format the date of birth. From the Custom tab, in the Date subtab, choose the Date Time Formatter and drag it on top of the DOB. The Add Date Time Formatter dialog will appear. We'll enter in our expected input pattern of mm/dd/yyyy and our desired output pattern of yyyy-mm-dd. Note both the capitalization matters here and that a sample of the pattern will appear to the right using the current date and time. Once complete, click OK. We now have our reusable formatted DOB available to us. Now, double-click on the birth date attribute, and in the value text area, replace the hard-coded value with $ formatted DOB, and hit enter. The $ preceding a name is used to reference a variable that we've created earlier in the document. Now let's move on to the residence area. Expand the residence section. We'll need to map street address, city, state, and postal code. These all have straightforward mappings from our source. ADDR1 to street address, city to city, state to state, and zip to postal code. However, you'll notice that our source has ADDR2, a second line of the address, which isn't accommodated in this residence block. However, we can take a look at the MISMO standard to see if an optional attribute is available for our use. To do this, we'll navigate through the target tree to the residence node underneath the borrower. Note that as we navigate through the tree, any field that has documentation has a doc tab associated with it. Underneath the residence, we'll see street address 2. Take this attribute and drag it on top of the parent residence node. A new street address 2 attribute will be added to our output. However, it hasn't yet been mapped. As we did with everything else, drag ADDR2 onto the street address 2 attribute. We're almost done. We've come to the bottom of the mapping here, but you'll notice that we have an indicator to determine which of the 3 credit reporting bureaus we wish to check. This information needs to be mapped into the credit repository aggregate, which has an Equifax, Experian, and TransUnion indicator. First, map the Check Equifax field onto the Equifax indicator in our mapping. Now, our sample data will include an X if we want to check that bureau, and it will be clear or have a different value if we don't want to check it. So we'll need to map from X to the expected value of Y, or from any other value to an N. To handle this type of lookup type mapping, we'll use the Tabular Mapping tool. Underneath the Custom tab in the Uncategorized subtab is a Tabular Mapping icon. Drag this tool onto the Equifax indicator, and then click Define New. This will allow us to create a new type of mapping. Let's call this My Indicator Mapping. Since we want the default value to be no, enter N in the default value area. To enter in the mapping from X to Y, click the Add button. In the source text box, type X. In the target text box, type Y. Then click OK. The grid will be populated with one row representing a source to target mapping. Note that this grid can contain any number of values. Once you've completed this step, click OK, select My Indicator Mapping, and then hit Select. All of the code required to call out to that mapping to populate the Equifax indicator will be populated into your center mapping. Now, click on the Experian indicator. Again, drag the Tabular Mapping tool onto that attribute. Now we can select our previously created MyIndicator mapping and hit the Select button. This will reuse the existing tabular map for this additional field. We now need to repeat this process with the Experian and TransUnion indicators. Map check Experian and check TransUnion onto the corresponding attributes underneath Credit Repository Included. Now, again drag your tabular mapping tool onto first the Experian indicator. This time, when prompted to choose a tabular mapping, choose the one you just created, MyIndicator mapping, and hit Select. Do the same for TransUnion. We've now completed our logical mapping from our CSV format onto a MISMO credit check request. Click the Save Current Mapping icon and provide a name for our XSLT. Let's call it Credit RQ from CSV and click OK. Then click the Return to Console icon. You'll note that the XSLT file we just created is automatically populated into the XSLT configuration area. Next, click on the routing icon. In this stage, if we had multiple different target systems, we would be able to configure routing rules. This would allow us to inspect XPaths or attributes of the inbound data, and based on that, determine which target systems we should send the data to. In this case, we're sending the data along to all defined targets, the one target that we've created. The routing stage is also where we configure transaction monitors. Transaction monitors are the XCS eiConsole's mechanism for proactive error reporting, whether it be an email to operations staff, an SNMP trap for a piece of monitoring software, or an error route trigger to invoke another route or interface to handle the error. This is how you set up that type of proactive response to an unexpected error condition. In this case, we won't configure routing rules or transaction monitoring, and we'll just move on to the target transform. The target transform is where we'll take the data from our canonical format and we'll lay it out into a format that the target system can most easily consume. Now, if the target system can consume the standard that we've provided and it's on the same version and uses the same interpretation, no further translation is required here. However, if you need to go between versions or interpretations, or you need to lay out the file completely differently so the target system can consume it, you would add a new format. To add a new format, we would click the Add Format button. Let's click it and just add the name Credit Check Format and hit OK. Now, a default transformation won't do anything further. It's just going to take the data and pass it along to the next stage. And that's what we'll leave it at for now. Next, click on the transport icon. The transport stage is very much the mirror image of the listener stage. We have a number of different transport types that allow us to handle connectivity to the target system. This connectivity can be batch-oriented, it could be real-time, it could be something that's asynchronous or synchronous. In our case, we're just going to drop the file in a directory, so we'll choose directory from the transport type drop-down. For the target directory, we'll create a new folder on our local drive. Click the button next to the target directory and create or select a folder called Output. In the target file name area, we'll enter in the name of the file we wish to create. Let's call it MISMO Credit RQ. In the target file extension configuration item, we'll need to enter the extension we wish the file to be created with. Since it's an XML file, let's enter XML. Now we're pretty much done. The target system will receive the data and handle it however it needs to. What we can do now, however, is go back and apply some metadata to the source and target systems. Source and target system metadata is purely informational, but it helps us get a sense for what an interface is really doing. Click on the source system and enter in loan application. Then click on the target system and enter credit bureau. We've now completed configuring the topology of the interface. To save our work, under the File menu, select Save Current Route. Then, under the Route menu, switch to Testing Mode. In testing mode of the eiConsole, we can test any number of different stages of the interface together, or an individual stage. The green and blue arrows will indicate the stages of the test that we want to run, with the green arrow indicating the starting point. By default, a test will begin at the listener and run through to any defined transports. However, let's start by just testing our transformation. To do that, click on the source transform stage, and in the Objects Within Selected Stage grid, select Start Test here in the stage configuration area. Then, click on the XSLT stub stage and click End Test After here. You'll see that now only the source transform has an arrow associated with it. And in the Object Within Selected Stage area, you see a green arrow indicating that we'll start with our file specification change, taking the CSV file and converting it to XML. We'll continue with an unused forking stage, and complete after having executed the XSLT, the mapping of the XMLized CSV onto the MISMO credit check request. Click the Execute Test button. When we do this, we'll be prompted with a dialog asking us to provide a sample file to start the test with. Choose the CSV file in the Tutorial Data folder and click Open. As each stage completes, we'll either see a green check mark or a red X. A check mark indicates success, a red X indicates failure. With the starting stage selected, I can also hit the View button in the stage configuration to see our input. Our input looks fine. Now I'll double-click on the Delimited and Fixed With File stage, and this will show me the data as it appeared after being translated to XML. Again, this looks like it was parsed appropriately. Now I'll click the red X on the XSLT stage. Since my error is in the XSLT stage, I'll want to save the input that went into that mapping, return to the Datamapper, and debug. To do this, I'll click the stage immediately preceding the data mapping, double-click, bringing up the stage output viewer. Then I'll click the Save Results icon. Let's name the file applicants.xml and click Save. Now I'll want to return to editing mode by choosing Route, switch to editing mode. I'll click on my source transform, and in the XSLT configuration area, hit Edit. This will again launch the Datamapper. Now I'll want to test that XML input right within the mapper. Click the folder icon. This will allow me to choose a source XML file. Choose the applicant's XML sample that we just saved aside and click Open. Then, to execute our XSLT against this sample, click the Execute Transformation button, the gear in the upper left. You'll see the detailed error message appear in the output area. If we click on the XSLT view, we'll also see the error line highlighted. I can see that I have a typo in the unparsed name attribute. When we manually typed in the concatenation function, we forgot a cold closing parenthesis. I'll add that parenthesis within the XSLT view and return to the testing view. I'll click the gear again. This time I'll see my transformation complete successfully. I'll save my changes and return to the console. Now I'll go back to testing mode and try again. Again, under the route menu, I'll switch to testing mode. If prompted, I'll save the route changes. I'll click on the source transform. I'll choose to start my test at the delimited and fixed width file transformation module. I'll choose on the XSLT stage and end my test after that point. I'll then click the execute test button and provide my CSV sample. This time, all three of those stages complete successfully. I can double-click the XSLT stage to view the output. You can see I've created two request data sections, each with its unique credit request and loan application info. Finally, I may want to do an end-to-end integration test incorporating both the listener and the transport. To do this, I'll click the Clear Test Configuration icon. Then I'll select the listener stage and choose Start Test here. Now I'll click Execute Test again. This time, rather than prompting me for sample data, a dialog will appear indicating that the listener is engaged and waiting for data. In order to invoke the interface, I'll need to take the sample data and copy it into our defined input folder. To do this, I'll locate my applicant CSV file, I'll copy it, and I'll paste it in my defined input folder. Within seconds, the file should be deleted and green check marks should appear from left to right again across the screen. Now, if I navigate to my defined output folder, we should see the final output file created. You've just completed building your first XCS eiConsole for MISMO interface. To review, we created a route in the File Management window. We then worked our way from left to right across a number of different paint-by-numbers stages configuring the behavior of the interface. We spent the most time in the source transform, configuring first the structure of our input file in the file specification editor, and then the mapping to our canonical format in the Datamapper. In testing mode, we unit tested several stages and integration tested the full interface. Typically, the last step is to take our interface and the configuration files that it creates and deploy it to an EI platform server. For more information on how to deploy an interface to the EI platform server, please consult additional documentation or the PilotFish website. This completes the XCS eiConsole for MISMO Getting Started tutorial. We hope you've seen how quick and effective it can be at allowing you to create MISMO-compliant interfaces between two heterogeneous systems or entities. Thanks very much and happy interface development.